this question was a question from exam 1 that was different from the practice exam, and so it's in the final exam review pack, and so you get a new video. So what is this anyway? An angle whose cosine is 3/5. This mess, which is theta, is an angle whose cosine is 3/5. Okay, and this is very similar to some other questions we've done, but they were just posed slightly differently. Okay, but if I have a theta right here, and the cosine is 3/5, that's, you can think of SOHCAHTOA, adjacent over hypotenuse, or you can think cosine is x/r, whichever you prefer. This happens to be a Pythagorean triple. So if you don't know that that's a 4, you can solve for it. Okay, so 3 squared plus something squared equals 5 squared, and you solve and you find that it's a 4. Okay, so now we want sine of theta, and that's y over r, or so in SOHCAHTOA, opposite over hypotenuse. And that's all we're actually doing. All right, let's try it again. Next question, sine, an angle whose sine, so theta, is equal to angle with sine of 5/13. Okay, so here's my theta. Sorry about the messy drawing. We'll try that a little better here. There we go. Okay, an angle whose sine, whoops. So what is this missing piece? Well, it's actually another Pythagorean triple, and if you don't recognize it, you solve for it and you find it's a 12, 5, 12, 13. And now we want the tangent. So the tangent of this magic angle, we never have to find the angle. Guess what? It doesn't actually matter what theta is, we just draw the triangle. Now, if you figured out the theta, you could figure it out using your calculator, and then you can plug it back in. And in the case of sine of theta up above here, you would probably get the right answer, because 4/5 comes out to be 0.8, and that's an exact answer. So in that case, you'd get away with it. The tangent of theta here is x over r. Well, let's see. It may come out to be some weird decimal, so you may or may not figure out that it's 5/12, but, you know, you would at least get partial credit. And it also does not say find exact values, which is usually what I say when I want to remind you not to use your calculator. So I would probably say, well, okay. And it would really probably depend on what you did downstream in parts C, D, and E. If you got C, D, and E correct, and then you give me a decimal in part B, I'd probably say, that's good enough. They know what they're doing. So all these questions are really supposed to be testing the same thing, right? They don't look like they are, but they really are. And so let's draw ourselves a triangle here. And here's theta. And we want an angle whose tangent is t. Tangent is y over x. So we don't know what the hypotenuse is, and so we're going to have to figure it out. Well, I don't know. It's going to be the square root of the sum of the squares of the other two sides. Okay? So what is the cosine of this guy? Well, it's x over r. There you go. That's what's going on here. Alright, now what? Well, this is an angle. Now, if you don't notice that there's sine and angle whose sine, they're inverse functions. But let's say for a moment that you didn't notice that, and you just blindly went ahead and made yourself a triangle. What would you say? Well, an angle whose sine is, what is sine? Well, the sine has to go on this side over the, what's going on? Sine is y over r. Okay, that's fine. then, well, what is down here? I don't know. Who cares? It doesn't actually matter what's down there. You can solve for it. It's completely pointless. It will be 1 minus quantity squared, t squared plus 3t plus 1, all under the square root. It's just a royal mess. However, the point is we want to take the sine of this angle, and you're like, wait a minute, sine of theta is just t squared plus 3t plus 1. And you're like, huh? That's all it does? And then you look and you say, oh, I'm combining a function and its own inverse together. Of course that's what's going to happen. I wouldn't expect anything different. Put this angle over here. It's hard enough to draw triangles, I guess. Alright, now this guy down here, you may think, okay, this is a mess, right? Not really. Okay, we want an angle whose cotangent is this mess. Okay, so what is that? That is x over y. So this top is going to be x. So I'm going to put this down here. This isn't really necessary if you can see through this question. And then y is down here. And then this side is who cares? I don't care because I'm not going to ask you for it. It would be a huge mess. I'd have to square the two legs, add them together, and then take the square root. But I'm not going to ask you that. That would be crazy. And the tangent of this guy is just y over x. Y over x, which is just the reciprocal of what was inside. And then you look and say, aha, tangent and cotangent. They are very, very similar. One is the reciprocal of the other. So a tangent of an angle whose cotangent is mass is 1 over mass. Just like the sine of an angle whose cosecant is mass is 1 over mass. So we're good to go.